All right, here are solutions for perfect problem 7 for Math 211. On this problem, you're told that I'm thinking of this 5-digit number, and when you write it in base 8, it ends in 2 zeros. So what does that tell you? It gives you a lot of information, but it's kind of tricky to figure out what information that gives you. When I write it in base 8, it ends in 2 zeros. Okay, think about base 8. In base 8, when you write a number, the furthest digit to the right represents how many groups of 1 you have, and then the digit to the left of that represents how many groups of 8 you have. And then left of that is how many 64s. And then less than that is whatever 8 times 64 is, 512, I think. And so on. So what does it mean? Maybe I'll even write like dot, dot, dot. This keeps going. If you have a 0 here, and then some number here, and who knows what you have out here. Well, what that tells me is that 64 divides evenly into my number. And why is that true? Well, you have some group of 64, so 64 can certainly divide evenly into that number. And then whatever number of 512s you have, well, each 512 is just a whole bunch of 64s. So 64 can certainly divide into some number of 512s if it can divide into some number of 64s, because 64 divides evenly into 512. Anyways, this all just tells me that 64 divides evenly into my number. And similarly, when I write it in base 3, it ends with 3 zeros. So that's going to give me some other number that divides evenly into my number. What number? Well, you might not need me to write this out, but I'll do it anyways. In base 3, these are kind of what my digits represent. And so it ends in 3 zeros. So what that tells me is that 27 divides evenly into my number. And then finally, we have that in base 5, it ends with 2 zeros. And so by the same logic, I guess I've gone this far, I might as well draw them all out. If it ends in 2 zeros, that means that 25 divides into my number. Okay, so what? How does that help? Well, if you think about the prime factorization, because 27 divides evenly into this number, it must have at least 3 3s in its prime factorization. It must be 27 times some other number. Similarly, because 25 divides evenly into my number, there must be at least 2 5s in here. And because 64 divides into my number, you could write 8 squared, but I'm not going to because 8 is not a prime number. I'm instead going to say that 64 is 2 to the 6th power, and that must divide evenly into my number. And that might not be it. There might be more stuff in there. So maybe I'll write times question mark. But let's see, all we can do is make our number bigger by multiplying it by stuff. So what do we get when we do 3 cubed times 5 squared times 2 to the 6th power? I think I'm going to pull out a calculator to do this. Probably could do some mental math if you really felt the need. But I'm just going to say 3 cubed times 5 squared times 2 to the 6th power and get 43,200. Yeah. This is a pretty big number. Remember, the final answer has to be a 5-digit number. So maybe this is my answer right here. Is there anything else that could possibly be my answer? Well, there is. Any multiple of this number will still satisfy all these criteria. So if you multiply this number, so maybe 43,200, or a multiple of it will satisfy this criteria. But in order for it to just be a 5-digit number, I can't multiply this by a very big number. In fact, if I multiply this by 3 even, that'll make it a 6-digit number. So the only thing I can multiply this by without having it, the only positive integer that I can multiply this by, other than 1, that will keep it a 5-digit number is the number 2. And if I multiply by 2, I get 86,400. So what I've managed to do is narrow things down to just two different possibilities. So then how do you figure out which of those work? Well, there's one more piece of information. When I write it in base 11, it ends with a 6. So if I do 11 divided by, I'll use my standard long division algorithm, 43,200. Maybe I'd throw a 3 up here. And then when I subtract, I get 10 and bring down a 2 to get 102. And I can throw a 9 up here because 9 times 11 is 99. And subtract, get a 3, bring down a 0. I can throw a 2 up here, get 22. Subtract, get an 8. And then throw a 7 up here, I get 77, which after I subtract, I get 3. So what that's saying is that 11 does not divide evenly into 43,200. Oh, but it wasn't supposed to. How many singles was I supposed to have? Well, I was supposed to have 6 singles. Looks like I only have 3 singles, not 6. So that is not my answer. So by process of elimination, this must be my answer, 86,400. If you wanted to check that, you could. Make sure that when you take 86,400 and divide 11 into it, that you end up with a remainder of 6. Well, let's see what happens. I can throw a 7 here. That'll give me 77. If I subtract, I get 9. Bring down a 4. 8 times 11 is 88. So I can subtract that from 94 and get 60. 5 times 11 is 55. If I subtract, I get a 50. And this is going to work. And throw a 4 up here. 4 times 11 is 44. Subtract, you get a 6, which is awesome. What that means is that if I were to write this number, this is in base 11, I'd have a 6 in the single spot. So what that means is this is my answer.